else than the head count. Hey, well, good afternoon, everyone. Today we'll be doing section 3.2. This is on measure of dispersion. 3.2, it's on measure of dispersion. Dispersion meaning the spread of data. So we're really going to look at, we're going to come up with numerical values to determine is the data really spread out, or is the data all close together? Before we get into that, the last thing we did was we talked about measure of central tendency with mean and median, and I want to do an exercise with the median because right at the end I was talking about how if your data is skewed, so if you got skewed data, then for the middle, when you come up the center, it's appropriate to report the median, right? Now, if your data is, roughly symmetric or bell-shaped, solid symmetric, bell-shaped, that bell-shaped design where it's like this, the graph went up and goes back down, then for the middle, for the center, it's good to report the mean, all right? So if you want to talk about the center, we'll report the mean. So it's important to know, but why? So I'm just going to give you an exercise, some numbers of why the median is a better representation of the center when your data is skewed. And I mean, just the idea here, I've got the numbers, let's say 10, 12, 16, 20, and 1 million. So you get 10, 12, 16, 20, and a million. We're going to compute two things. We're going to compute the mean and the median. All right? Feel free to use your calculator too. I think for the median it's going to be real easy. What's the median of this group?
16.
It's the middle, right?
Mm-hmm.
The middle number's already been sorted. 10, 12, 16, 20, 1 million. I didn't put commas in the million because I didn't want you to get mixed up with these. The median's the 16, right? Sitting right there in the center. Well, what's the mean going to be? I'll let you calculate it. So for the mean, we have to do what? Add up all the values.
Divide by 5.
And then divide by?
And 5.
Yeah, the sample size 5. There's 5 of them. Divide by 5, right? So add them all up. And you can do it. Someone will come up with an answer. Remember, I like to get someone to double check that for me. And we'll come up with this. You get an idea that it's going to be fairly large, isn't it? There's one player in that group. We'll call them players. There's one player who's really influencing this value, isn't it?
Outlier.
That's what's going to happen. So what do you get for the mean? So I add them all up. This plus this plus this plus this plus this. Divide by 5, right? What do you get for the mean? What'd you get?
200,011.6.
200,000 and 11.6. And I got a head. She's like, "Yep, that's what I got." So, what the heck's going on here? What's a better representation of the center here? The median, right? What did this one crazy value? We'll refer to it as an outlier. It's way out there, an outlier. What did that one value do to the whole group? It big time influenced it, didn't it? Had a major influence on it, and that's what can happen. So when you get data that's, when it's skewed, I'll go back and draw some of that. I'll get my razor. You have skewed data, we know what they look like in a bell shape. That's bell shaped, but skewed, it might look like this, and you got a lot of values here. But when you get these numbers that are way out here, you get a few of them, and they're way far away, these gigantic numbers like what? Like 1 million can have a major influence on what's going on here. And so when your data is skewed for the center, it's better to report the what? The median. All right. Secondly, would you write this down? The median is resistant to outliers. The median is resistant to outliers. And we'll do an exercise for that too. What do you mean by that? Well, you just saw it. That was one example. It resists those outliers, right? That 16 was sitting there right in the middle. Didn't let that gigantic milling affect it. Cool. Hey, just by the way, have anybody ever looked at like, you know, homes in a certain area, let's say like Anne Arundel County, and they give like the median home price? Have you ever noticed that? Mm-hmm. They always report the median home price. They never report the mean. It's always the median home price. If you're wondering why, it's because the data's skewed. It's always skewed. All right, so here's my exercise. All right, everyone, I gave a quiz yesterday, and I entered all these grades into Microsoft Excel. This quiz was out of 10 points, okay? So here's all the grades. And I'm talking on the telephone while I'm entering these, right? It was out of 10 points, you know. 2 students aced the quiz. I'm just entering it, and I'm talking, and I'm entering it. So you can see I made a typo. Does everyone see it? Mm-hmm. This quiz was only out of 10 points, but accidentally on this one, I was thinking 100%. What did I type accidentally? 100. So I made an error. All right, so now I'm going to fix it. I noticed it. I'm like, whoa, that student's average is way up there. So I'm like, oh, let me fix this. I got to make that 10. So I'm going to make the fix. 3, 5, 6, 10, and then I fix it. 10. All right, now it's fixed. Here's my question. This is before, this is after. I'm going to list some things over here. What's some measurements we've come up with over the past few days? Mean, the mode, the median. We did range, right?
No.
Oh, we'll do range today. But I'll just stick with these then. Mean, mode, median. The question is, which one of these 3 does not change? Which one does not change?
Median.
Between
The median.
before and after. I mean, look at that huge typo I had there. I fixed it. But with the before and the after, which one just did not change? We look at it. All right, if we do the mean, we got to add them all up, divide by 5, add all these up, divide by 5. Do you agree these would be different? Mm-hmm. All right, so it's not that one. How about the mode? Number occurs the most.
Yes, it does.
No mode here, but we got 2 modes. There it is, 10. So that changed. Who did not change?
Median.
Resistant to outliers. Resistant to outliers. I mean, it's just a small exercise, but it gives you that idea, that sense. It kind of helps, kind of stays in the middle, right? Doesn't let those crazy big numbers affect you. Especially when you get like 3 or 4 outliers in a row. The median will hold on and keep it right in the center. Hey, so today we're going to measure dispersion, and the first word that I like to talk about is the word range. This is a very simple formula. The range. Put this in there, so the formula sheet, attach your test. You know, throughout the course, there'll be like 3 formulas that are not on that formula sheet. One of them is range. Well, it's a very simple formula. It's just your highest value minus your lowest value, which I'll write as max minus min. So to find the range, it's just your max value minus your min value, your maximum value minus your min value. I'll erase that, sorry. So can you find the range of these 2 data sets here?
Before or after?
Do them both.
Okay.
What's the range?
97 and 7.
Good, 100 minus 3, 97. Max minus min. What's the range of this one? 7. So did the range change?
Yes.
Yeah, I can add it to the group. It's still, that's one of these that would, median's still the only one that does not change. Resistant to the outlier. Well, that was a simple math formula. The one I'll take up the most today is something called the standard deviation. So you and I are going to find the standard deviation. Okay. For example,
we're going to do this by hand. We're going to know how this math formula works.